Okay, this is for worksheet 4.3 for element compounds and mixtures. So let's jump straight into it now. So question 1, what is a molecule? So this is a definition question. What is a molecule? We can find the answer from the textbook. However, what actually is a molecule is when you have two or more atoms that are chemically combined together. So for example, this is an atom. This is another atom. When I combine them together, it looks like this. So you can see I got two atoms. When I combine them, it's touching one another. This is what we mean by when I've combined them together here. So this is considered a molecule. Now, two atoms joining forms a molecule. If I have three atoms joined together, it could possibly look like this. Three atoms joined together, this is also considered a molecule. That's why they say it's a group of two or more atoms that chemically combine together or join together. So that's a molecule now. Okay, let's look at this here. Identify the number of atoms present in a molecule of the element and classify the molecule as monatomic, diatomic, or polyatomic. Maybe let me change the word here. It shouldn't be in a molecule of the element, okay? In the element, okay? In the element. And then classify the type. Okay, just classify the type. Could be monatomic, diatomic, or polyatomic. Monatomic means one atom only. The word di means two atoms. Polyatomic actually means three atoms or more joined together. Okay, so for xenon, look at this here, Xe on its own. So there's only one atom of Xe. Is considered monatomic because one atom of the element. Now nitrogen, can you see N2? This 2 tells you that I have two nitrogen combined together. So that's why two atoms of the element forms it. So this is considered diatomic element or diatomic substance. Ozone, O3, so one oxygen, two oxygen, three oxygen combined together. You can see here. So O3 is actually three O's combined together. This is three atoms. So we call it polyatomic because it's three or more. But in actual fact, there's another term we can use. It's called triatomic. Tri means three. So three atoms combined together. Last one, sulfur is S8. It's actually quite nice. It actually looks like this. It's like a little ring. So 8 sulfurs combined like this. So it's 8 atoms combined together. We call it polyatomic. So this is the first example here, learning how to identify how many atoms there are. Now the next one. Okay, indicate by shading the position of the elements which always exist as a diatomic molecule. Now, which elements always exist as diatomic? They are actually what we call the H7 elements. So which means H, hydrogen, plus 7 other elements. What are the other 7? Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, astatine. Can you see it starts from element number 7? Actually, nitrogen is element number 7. You go to group 7, go horizontally to group 7, and then you go down all the way. So H plus 7 other elements, and you can see this forms the character 7. 1, 2, 3, 4, 5, 6, 7, 7. Okay, so what does it mean by they always existing as diatomic? So for example, if I ask you what's the formula for hydrogen, hydrogen exists as a diatomic molecule, so the formula will be H2. What's the formula for nitrogen? It will be N2. Oxygen, O2. Fluorine, F2. Iodine will be I2. Astatine will be AT2 because they exist as diatomic elements, diatomic molecules. Okay, so write the chemical symbol of the following elements. Do take note. Simple way of looking at this is all elements will be equal to their chemical symbol. So chemical formula the elements will be equals to the chemical symbol, except for H7. Except for H7 elements. Okay, what do I mean by that? For example, helium. Helium, okay, is it part of the H7? It is not hydrogen. It's neither one of this. Helium is actually over here. So if helium is not H7, it means the chemical formula will actually be just the chemical symbol itself, right? Just He. Neon, same thing, is not part of H7, then it will just be the chemical symbol itself. The chemical formula of the element will actually just be the chemical symbol itself. Same thing for argon and for krypton, they are not H7. But for E, for G, for I, for F, for H, for J, for K, and for L, okay, all these elements here, they are part of the H7. So since they are part of H7, you realize the chemical formula for each of these elements is actually the chemical symbol with a 2 at the bottom here to indicate that they are diatomic molecules. Okay, so these are all diatomic molecules. So these elements exist as diatomic molecules. How about the rest? Calcium, aluminium, magnesium, sodium. These four, they are not part of H7. As such, their chemical formula is just the chemical symbol itself. Okay, so this one here, just need to take note of it. Key idea here is that all elements, okay, that are not H7, the chemical formula will just be equals to the chemical symbol. If it is H7, you need to add 2 to it. Okay, so do take note of this. That's all from me. So this is for worksheet 4.3.